So, all right, we're going to the next session, and this is for Alluxio fans. So, last week on October 18th, Alluxio launched a new product called Alluxio Enterprise AI, so which accelerate AI products time to value and also maximize your infra ROI. Now, in the upcoming session, we will have Adit Madan, who is the Director of Product Management at Alluxio, to talk about how to accelerate the model training with Alluxio Enterprise AI. Shall we get started? So there's no sound there. I think while you are sharing your screen, you should choose to share your screen with sound.
Hi everyone, I'm Adit Madan, Director of Product Management at Alluxio. Today I'm going to talk about how to accelerate your model training with Alluxio Enterprise AI. Great, so let's begin. As you may know, Alluxio is a software-defined solution in the data infrastructure stack, uniquely placed at the intersection of storage and compute. What we do is we bring efficiency and ease of access to data. Our existing customers use Alluxio to scale out the capacity of their data platform, but also adopt a hybrid and a multi-cloud strategy. A little bit of context before I dive straight into it. We began as a sister project to Spark in UC Berkeley's AMP Lab. This is when a lot of folks were migrating away from Hadoop and embracing the separation of storage and compute with the data lake model. Along the way, we also helped a lot of enterprises migrate to the cloud and adopt a hybrid and multi-cloud strategy, but also make sure they're able to perform analytics over their data real estate, which may span multiple regions in a same cloud. That's what brings us to today with what we're talking about really when we're talking about model training is the use of deep learning frameworks in order to train different kinds of models all the way from convolutional neural networks to RNNs and also LLMs and VLMs. So I'm really excited to share that we have Alluxio being used right now to empower critical workloads at AliPay as well. A lot of their model training applications are now powered by Alluxio. So let's dive straight into it and talk a little bit about what is Alluxio Enterprise AI. Now, if you look at the offerings from the Alluxio Data Platform, we have the first commercial product, which is Alluxio Enterprise Data. This is something which serves the needs of different data and analytics frameworks, the logos that you see on top. So a lot of SQL workloads and a lot of ETL workloads running on top of Alluxio, making use of Alluxio Enterprise Data for some of the capabilities that you see in the boxes below. Now, Alluxio Enterprise AI is purpose-built for the needs of deep learning and other AI ML training frameworks such as PyTorch orchestrated by Ray when accessing data either on premises in the same cloud or even across a hybrid cloud. So let's talk a little bit about the capabilities, and before I do that, I'm going to introduce the problem just a little bit more. So data access in AI ML, especially with specialized compute hardware, is a well-recognized problem. And high performance IO and high performance access to data with this specialized compute hardware is not always easy. So that's the first problem that we're going to talk about. Now, the second problem that we're going to talk about is the scarcity of GPUs, and the ability to use GPUs wherever you can find them. So that's the number two to keep in mind, that we are enabling folks to leverage GPUs where they are, even if it's separated from the primary data lake. Now, while we are doing all of this, we all recognize that specialized compute hardware, if you're talking about large pods of DGX servers, NVIDIA DGX servers, for example, these are fairly expensive. So upwards of a couple of $100,000 per server, and managing the cost, even though sometimes a secondary concern, is something that needs to be kept in mind. So what's new in Alluxio Enterprise AI? We have two things highlighted on the screen over here, and the first one is a brand new architecture which we're calling DORA. DORA stands for Decentralized Object Repository Architecture, and it's a revolutionary new architecture which is able to provide high performance IO over commodity storage itself. Now, commodity storage is what your primary data lake may be, and DORA is able to co-locate with the GPU hardware itself without the need for a specialized storage system to provide high performance IO. The second highlight that you see on the screen here is the fact that Alluxio Enterprise AI is something which is applicable across different stages of the pipeline. Whether you're training large language models or doing natural language processing or computer vision, and like I said, if you're training multimodal models, this is something which is applicable across data pre-processing, model training, and also serving the models once the models have been trained. Now, first up, the new architecture that I talked about. This is a brand new architecture which is significantly different from what we had before. Alluxio Enterprise AI comes with what we call DORA, and DORA is a completely distributed architecture, as it says in the name itself. It is completely decentralized and scales out to the limit of the data center. There are no single points of failure in this architecture, and we are able to provide high availability by providing automatic fallback and the ability to go straight to your primary data lake storage in case you have undersized the Alluxio cluster or are encountering any other challenges. Now, it also comes with a revamped single node storage engine which caches at a much more finer granularity than what you might have been used to if you are an existing user or customer of Alluxio. I'll talk a little bit about the workload specific optimizations for model training and analytics in just a second as well. Now, this system that we have, DORA is the backbone, and that's kind of what I'm highlighting on this slide here. Okay, now let's talk a little bit more about model training. Like I was saying, model training, we are talking about typically the use of compute engines like PyTorch to execute deep learning and other kinds of training jobs on top of your primary data lake. Now, you may be a very large enterprise whose primary data lake is in the hundreds of petabytes, or you might be smaller than that. So, or you may be operating with tens of terabytes or hundreds of terabytes of training data itself. Now, the need for Alluxio arises really when you're ready to scale out from training on a single server to multi-server training. Now, one of the major differences and the reason why we have the need for the new architecture, which I introduced on the last slide, is that the characteristics of model training tends to be very different from the typical analytics workloads. Analytical workloads, they operate on larger files with hundreds of megabytes, or each object being hundreds of megabytes, whereas you may be an autonomous driving company who's training on a lot of small images. In this case, the amount of files that you're operating on would be in the billions instead of being in the hundreds of millions. Now, that's why we introduced an architecture which really is able to sustain the high throughput requirements needed from the specialized compute hardware used for model training. Now, the other thing that Alluxio Enterprise AI does for model training is the POSIX API, and also a RESTful interface for Python applications to talk to the Dora backbone on the previous slide. A POSIX interface is an easy to use interface. If you're used to training on a single node, you can go from training on a single node to training on a cluster of nodes, which may be in the hundreds or even more, as if it was your local machine itself. So Alluxio exposes a POSIX interface and gives you access to your primary data lake, distributed storage, as if it was available locally on your training machines itself. Now, if we're talking about a hybrid cloud model as well, you don't need to worry about network egress. You don't need to worry about scaling your IO throughput. Under the same familiar interface, you are able to get access to your data. Now, I was mentioning, if you're a large enterprise, you have a few different options in front of you. You may want to procure a high performance storage system, typically parallel file systems, which have been repackaged for the needs of deep learning and other kinds of machine learning. Or you may want to hack around and develop some scripts to copy data from your primary data lake onto your training servers before you begin the first epoch of your training job itself. Now, the solution that we provide is an alternative to both of these. It's easy to maintain, it's scalable, and it also does not need you to provision extra hardware resources, but you're able to sustain the high IO throughput by Alluxio Enterprise utilizing the NVMe resources, which may be available on your training servers themselves. Now, if you look at a few of the numbers that I have over here, and when you are training on top of a commodity data lake storage like Amazon's S3 with the caching capabilities that Alluxio Enterprise AI provides, you may see performance benefits anywhere between 2 to 8x. Now, these are end-to-end training time performance differences, so it's pretty significant on its own. Now, also, if you are working on a small volume of data with a few servers only, API costs may actually end up dominating a lot of your storage costs. So not just static storage, but API cost may dominate a lot of your storage cost. And since the compute cost may be small in these scenarios, it actually may be a significant part of your cloud bill itself. So that is also one way that Alluxio Enterprise AI helps bring down the cost so that you can do more with less. Now let's look at other stages of the training pipeline. Once the model itself is trained, Alluxio Enterprise AI is also able to serve the models to the inference clusters. Now, these inference clusters might be in the thousands, and once the model itself is trained, not just is Alluxio able to serve the training data to the training servers, but also serve the model itself to the inference clusters in themselves. Now, by making use of Alluxio's position in the data stack, Alluxio is able to detect the specific access patterns of model training and model serving applications to preload data from a remote data source into Alluxio managed storage, so that Alluxio can reduce the time it takes for the model to be served to the inference clusters. Next, I'm going to talk about an example case study of an early adopter of this platform. This is the APAC equivalent of Quora. So think about them as a content company for whom training this large language model was business critical. So they have large volumes of text data which they accumulate from their website, and they're training a large language model with the goal of improving user engagement on the platform. So while the user is engaging with their platform, they are able to train and refresh their models in the matter of a few minutes, and this is important to drive user engagement, which is a key metric tracked by the business. Now, there's a lot going on this image, and without going into all of the specific details, something to notice here is that the infrastructure is spread across training clouds, multiple clouds, and also multiple regions. So, training and fine tuning is happening on top of an object store. Alluxio is serving training data to the training nodes, and at the same time able to improve efficiency of the GPUs, the specialized compute hardware. In this case, without using Alluxio, they were only able to utilize 50% of their GPUs. Only the GPU utilization was as low as 50%, and by using Alluxio, they were able to bring this percentage up to upwards of 93%. So what this means is that by the efficiency that Alluxio provided, their platform, they had almost twice the capacity to do more, to be more iterative, and to get this initiative to market much faster. Now, another thing which is not on the slide, but it's interesting to notice, is that this was all done really with one full-time platform engineer working with Alluxio. So the other aspect of this is that because of the simplicity that Alluxio provides as a tool which is applicable across multiple stages of the pipeline, with one engineer, one platform engineer, they were able to get this initiative to market in as little time as 6 to 8 weeks, which is pretty impressive by any standard, especially for a new product that we are launching. Next, I'll go a little deeper and introduce the three key problems once more, elaborate a little bit on the three key problems that I talked about, and in a little bit on the case study slide itself. Now, if you look at what Alluxio does for model training pipelines, I mentioned increasing GPU utilization as the first key metric. Now, this is a metric which is highly important, and the GPU utilization really depends on how efficient access to data is. In some cases, this may be as low as 20% if you're operating on slow object store, or this could be 50% like in the example before. So it really depends on the speed and the distance to your storage. So if you're operating, for example, in a hybrid cloud mode, you may be utilizing GPUs on premises to access data in your public cloud like Amazon on S3, and we are able to provide nearly full utilization of your GPUs even if your data is coming from far away. So the other thing to notice is more easy access to data also improves your accuracy, which may be the metric that you're trying to optimize for. Some quick benchmarking. If you look at direct access to S3 for a typical micro benchmark used in the computer vision world, when performing this training job on top of Amazon S3 directly, you may see low utilization of your GPUs. In this experiment that was conducted, the utilization of GPUs are measured by a dashboarding tool called TensorFlow, and the utilization was as low as just under 20%. Now, when Alluxio was used for the same training job with PyTorch, we observed that the utilization of GPUs went from 17% to 93%. Now, this is almost 5 times as fast as performing this job without Alluxio. Now, moving on to elaborate a little bit about the concepts that I introduced before of the ability to perform model training directly on your data lake. Now, if you're a large enterprise and you are sitting in the AI Infra team or the AI platform team, you may be accessing your data from a sister team such as the data team, the data platform team. Now, the data platform team typically would be utilizing a commodity object store either on premises or in one of the three clouds, if not using the premium offerings, which tend to be fairly expensive. And in these cases, what we are saying is that instead of pulling in the data from your sister team into a specialized storage system that you replicate into as part of the AI platform team, you are able to simply point Alluxio to the data lake that your sister team is maintaining, and uh, the jobs from the data scientists that you're serving are able to simply access data which is coming from the primary data lake. Now, this really eliminates the need for any kind of specialized storage or redundant storage that needs to be maintained across teams in a large organization. Okay, so the third bullet related to model training, I talked a little bit about the ability to spin up GPUs wherever available, and a little bit also about the scarcity of GPUs. Now, we've seen interest in being able to utilize, even if your primary data lake resides in the cloud, in interest in the ability to utilize GPUs wherever you can find them. So this may be GPUs that you want to use in your on-premises data centers, but also in specialized GPU clouds like Lambda Labs or CoreWeave. So you're able to scale up your new machine learning initiatives by using GPUs wherever you can find them. You may want your primary data lake in the cloud because it's full featured and it has all of the other services that you need for the data side, but you may want to utilize some specialized clouds for your AI infrastructure. Now, with Alluxio Enterprise AI, this is made really easy, and you can simply point to your data and scale out your capacity by spinning up GPUs wherever they are available. Okay, so last up is, what does Alluxio Enterprise AI do for model serving? Now, if you look at what happens after the model is trained, these models may be a file of a few hundred gigabytes. Now, these models need to be distributed to multiple servers, possibly across multiple clusters, possibly spread across multiple regions as well, to be close to where the inference clusters are, so that they can be close to the users who are accessing them. Now, in these scenarios, what we see is the access pattern is such that multiple servers, there is a need for multiple servers to have highly concurrent access to the same data. And by using Alluxio, we are minimizing the amount of traffic which is moving across regions and also moving across clusters. Now, efficient utilization of the network enables us to distribute these models to really large inference clusters which are serving, or which are being used for inference. Now, like I was mentioning in the case study before, in the APAC Cora's case, what this enabled is the ability to train and distribute models in the matter of a few minutes instead of waiting an order of magnitude larger, which was really important for the freshness and to improve the efficiency and engagement of the user on the platform. Thank you everyone for listening. Thank you for your time. In case you are interested in exploring more, stay tuned. There's a lot more coming. I encourage you to explore the documentation, the new architecture called Dora, and what Alluxio Enterprise can do for you. Thank you.
So Adit is not here live today. We will have Beinan here to answer the questions. Would like to introduce yourself a little bit, Beinan?
Hello everyone, I'm Beinan from Alluxio. I'm the architect of Dora.
Okay,
Yeah.
so we have a few questions here. The first one is from, so see how I pronounce your name correctly, from Bharat Joshi. How does easy access increase accuracy?
Oh, that's really a good question. Yeah, as they mentioned, by using Alluxio, we can have a high performance and also easy access to your storage. But it doesn't just mean you can save your cost, save your time. It also means you can in a certain amount of time you can train your model with more epochs. And also, I heard from the machine learning engineers, they spend a lot of time by the data preparation. They may want to copy the data from the cloud storage and then do the training. They might occupy their very expensive GPU machine for a long time, but actually the training time is very limited. So by using Luxio I think it's another Xiao mentioned in the chat. You can just training more epochs in the same time. This will give you a better, mostly it will give you a better accuracy of your model.
Yeah, thank you. And the question from Ron Potter is how to eliminate data copies when I have to move workload based on where GPUs are available. Data would be copied for the training job temporarily, at least for the duration of training.
That's another very good question. By using Dora, actually, the data is not really copied to your local disk. But it looks like the data is in your local disk because we are using fields, we can have a local POSIX interface. So it looks like you are just using a local disk to consume the data, but actually it's not because we are caching layer. So the data probably is still sitting on your remote storage on your S3 or HDFS. We just cache the most hard data and we put the data, I mean the training data in our fast storage, and in your training node, it actually is fetch data from our cache. This kind of data can be in your local disk, but it can be also in your neighbor training node. My assumption here is that you maybe have a 5 or 10 training node, so they can share the disk. You can deploy Dora worker onto these 5 or 10 nodes, and because mostly for the GPU training node, they have a better network, like B mentioned in his keynote. We have seen most training node now they have InfiniBand or something, so they can have a nearly local, actually sometimes beyond local speed, local disk speed to serve each other. So in this case, actually, the data is in Dora. It's not copied to your local, and also your training data is still on the cloud storage. Only the most hard data are cached in our Dora. So we switch the data, the partitions or whatever, from the S3 or other storage to Dora to speed up your training job.
Thank you, Beina. Another question from Chong Xiao Tao is data cache in memory or disk?
It's another very good question. We actually we still have a lot of argument about that. We support both. First, we support both. It can be on the memory, it can be also on the disk. But if you're using memory, it looks like you can have a better speed. But if you have a disk, you can have a much better capacity. But now, as we observed for many our both analytics and AI customers, looks like just using NVMe. The NVMe disk, because NVMe is using the PCIe's, and you can have maybe 10 or 20 NVMe disks in one single node. It can give you a really good bandwidth. We're just talking about bandwidth, not latency. Sometimes the NVMe's bandwidth can be higher than memory. I'm assuming you have a read. In this case, we highly recommend just use the NVMe as a single layer of cache to reduce your cost and also reduce the complexity of your caching. You can have multiple layers of cache, but now we highly recommend just use a single layer of the cache on the local NVMe's.
So right now, I don't see more questions coming. Thank you so much, Beinan, for the Q&A session.